Hello future engineers, welcome to my YouTube channel. If it is your first time to discover my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel in order for me to keep going and refreshed. This job is very tiring on my part, but I do not uh, consider it as tiring. I want to enjoy it, and for me to enjoy what I'm doing, then please do your share also. Thank you. So here is the next problem by Castigliano's second theorem. Find the horizontal, vertical, and rotational displacements at point A of the frame shown. EI is 20,000 kilonewton meter square. So we apply force P, which is positive rightward at A. Then let's select this as our sections. Then we only have 3 sections here. So take note that the moment in this section is negative px. The derivative is negative x, but p is 0, so it will still be 0. In this section here, the moment is negative p times 1.5 times x and negative 10x. There is partial derivative, although the value of p. So there are only 2 integrals, here and here, in this section. So EI delta A horizontal equals integral from 0 to 1.5 of quantity negative bx negative x dx. But remember, p is 0, so everything will be 0. Then in this section, plus integral 0 to 1.5 of negative b times 1.5 plus x, negative 10x. Then partial derivative is negative 1, quantity 1.5 plus x, derivative of this moment equation. Then in this section here, the moment is p negative b times 3, negative 10 times 1.5, and negative 5 times x over 2, so negative 2.5 x squared. The partial derivative is negative 3. Anyway, integral 0 to 3 of negative b times 3, negative 10 times 1.5, negative 10 times 1.5 in this section, then negative 2.5 x squared, and the partial derivative of this moment equation with respect to p is negative 3 dx. So setting the value of p to 0, the value of the first integral is 0. The second integral is integral of negative 10x times negative of quantity 1.5 plus x. 0 to 1.5 is 28.125. Then integral of negative 15 minus 2.5 x squared, quantity times negative 3, 0 to 3 is 202.5. So delta EH is equal to, combining, 230.625 over EI, and EI is 20,000 kilonewton meter square. We just divided by 20 to convert this to mm. So delta EH is 230.625 over 20. So delta EH is now 11.53 mm rightward. Then for vertical displacement at A, we remove this horizontal P, apply upward P. So take note that the moment at this section is P times 0, so it's still 0. The moment at this section is P times 0, although there is moment due to 10, but the partial derivative would be 0, so it's still 0. So there's only one integral. In this section here, the moment is px minus 2.5 x squared. So EI delta A vertical equals integral 0 to 3 of px minus 2.5 minus 10 times 1.5 minus 2.5 x squared. This is included. Then partial derivative of this equation with respect to p is x, so dx. So prior to integration, p is 0, So we just evaluate the integral of these remaining last two terms and next. So that would be negative 118.125 over EI. So divided by 20. So the deflection is downward again. So delta A vertical, the vertical displacement at A is 5.906 mm downward. So finally, we apply a positive couple counterclockwise at A as shown. Then uh, still there's no moment here, just the couple, but the couple is 0. So here there is, and here. So we have two integrals. Integral ei theta A is integral 0 to 1.5 of negative c minus 10x. Partial derivative with respect to couple is negative 1 dx. Then in this section, the plus integral 0 to 3 of negative c plus minus 10 times 1.5 minus 2.5 x squared. Partial derivative is negative 1 of this moment equation. Prior to integration, c is set to 0, so integral of 10x dx 0 to 1.5 is 11.25, and integral of negative 15 minus 2.5 x squared times negative 1, or integral of 15 plus 2.5 x squared 0 to 3 is 67.5. Combining, theta A is 78.75 over EI, and EI is 20,000 kilonewton meter square. 78.75 is also kilonewton meter square, so that would be in radians. And the rotation is counterclockwise as shown. So 3.9375 times 10 to the negative 3 radians. So that's it for this problem.